Welcome, and thank you for taking a short moment to learn about our guidelines to identify and fix the root causes of false positives in lateral flow assays. There is no singular root cause of false positive. It may come from multiple factors. The solutions are dependent on each customer's application, and in this video I will outline insights into the solutions to identify and fix the root causes of false positives in lateral flow assays. When customers change materials, for example the membrane, the blocking reagents or labeling, a false positive may be induced because the balance of the assay structure has been altered. We recommend you consider and take the simplest approaches to identify false positive issues in the lateral flow assays. A false positive is created by interactions which are not expected and results in test line variances. In other words, direct or indirect interactions between capture antibodies and detection antibodies are the ultimate root cause. To identify the driver for this issue, setting appropriate controls is of extreme importance. Without a control, it is quite challenging to figure out the mechanisms driving a false positive because multiple parameters have an influence on the assay. Let's discuss 3 consideration points for identifying the root cause of false positives. If you follow appropriate control and experiments, following these 3 points, you should reach the goal. We'll look at too high sensitivity, source of negative samples, and the labeling method. The first point is too high sensitivity. By changing any materials, the sensitivity of the assay may have increased, whereby the diagnostic line, which was not previously observed, might become visible. In this case, a simple solution is to dilute the capture antibody, for example by 1 to 2, 1 to 5, or 1 to 10. Dialing in the adequate dilution series is important to find the right balance. And please note that in some cases, a 1 to 20 or even 1 to 30 dilution may be needed. It's recommended to have a comprehensive dilution series. The second point is to evaluate the negative samples. What kind of samples are being used as negative samples? Is it a biological sample, which is considered a negative, or is it a buffer? Although buffers can be used as negative samples, in doing so you may still observe false positives. In this case, the root cause may come from the detection reagents. If you see a false positive with a biological sample, which is considered negative, you may need to consider using a human anti-mouse antibody, also known as HAMA. HAMA bridges the mouse monoclonal antibodies which are used for capturing and detection. The third aspect is the labeling method. Are you using colloidal gold, colored latex beads, or fluorescent dyes? Depending on the labeling method, the approach should be different. For example, preparation of gold conjugation is one of the steps which can frequently result in errors. If you're using colored latex beads, it's important to consider the size of the latex particles and the rated pore size of the membrane. And finally, if using fluorescent detection, the autofluorescence from the membrane and the sample buffer need to be considered. When you're facing any issues after changing materials, we recommend selecting the simplest solution first. Appropriate control is the key for the best approach. Let us review our 3 points to identify and fix the root cause of false positives in lateral flow assays. 1. Too high sensitivity. 2. Source of negative samples. And 3. Features of the labeling method. We are committed to providing you the best in diagnostic membranes and insights for fixing false positive issues. We look forward to hearing from you to discuss more about our membrane product line.